This symposium deals with the topic that I have, through somewhat accidental good luck, been studying for the last 40 years. And I'm calling this talk The Healing Power of Love, the Oxytocin Hypothesis. The first question I'm going to actually address is, what is love? Okay? Then, what is oxytocin? I'll argue here that oxytocin is the molecule that made us human. It allowed human intelligence, empathy, compassion. Oxytocin's protective, actually, in essentially every form of illness and disorder. So I'll start to ask the question I think many of us have, which is, can the knowledge of this ancient peptide hormone help to explain the healing power of love and safety, the capacity of love to cast out fear, to make us feel safe, and how and why is love so powerful? The origins of love and connection are evolutionary, and I'll allude to that as we go along. What we're discovering, and it fits with the ancient proverb, if you want to go quickly, go alone. If you want to go far, go together. There are different mechanisms existing that allow us to use love and fear, and of course, both of those are adaptive. So what's love? Well, love is usually defined by attachments and social bonds, and sometimes by a need to protect those that we love. I'm going to define love here as a complex of neurobiological processes that facilitates health, wellness, reproductive fitness, and even biological optimality, and I'll explain what I mean by that. So love and social relationships in general, and all kinds of associated perceptions of safety, can come in many forms. I'm going to now go to my second big question, and I'll come back to both of these as we go along. What's oxytocin? Well, oxytocin is basically a string of 9 amino acids configured as a ring and a tail. Many of you are not very interested in that probably, but by knowing what oxytocin looks like, we've discovered way back, we being the scientists who actually did this original work, chemists, that oxytocin was held together by sulfur bonds. These bonds allowed oxytocin to have a very high degree of biological activity, and actually to facilitate things like positive social behaviors, stress buffering, and good health. So oxytocin has bonds, and it supports social bonds, and it supports love. The idea of oxytocin as a stress hormone and a biological metaphor for safety is not new, but it goes back about 40 or 50 years. Oxytocin itself was one of the first hormones to be identified, and what made it different than the other hormones that are studied most often is that the source of oxytocin is the brain, specifically the area known as the hypothalamus. So shown in the slide, oxytocin is released into the blood supply, though, at the posterior pituitary. So it has to get outside of the brain for some of its actions, but it's also released, as the arrows on the right suggest, it's also released within the nervous system. A great deal has been known and discovered in the last 10, 20 years about where oxytocin acts, and perhaps during questions I can discuss that a little bit. Oxytocin, though, we now can say with great confidence it affects social behavior, it affects the autonomic nervous system, and especially interesting, I think, in this story I'm telling, oxytocin affects the immune system. And the immune system regulates oxytocin. It's a two-way street. This allows the body to adapt, protect, and heal. And it allows us to say the effects of oxytocin are most apparent, most obvious in the face of a challenge of stress, pain, or chronic inflammation. Again, I'll come back to this in a minute. Where did this story start? Well, it didn't actually start with birth. It started much before. But when mammals first appeared on the planet about 220 million years ago, we were unique. In fact, our original mammals and some of the more ancient ones don't actually give birth. They may still lay eggs. But we were unique in having to meet the challenge of incubating, if you will, our next generation inside of a figure we call a mother. And we also were unique in having to deal with one of life's biggest challenges, which is birth. But oxytocin does not simply, that's not its only job. It affects both sexes. It's not just a female hormone. And what it's doing is modulating stress and pain. Yes, in the mother, a woman with a fetus in the uterus, it facilitates uterine contractions in birth. It also facilitates the immediate mother-infant interactions and engagement. We begin to fall in love with our babies. It allows mammals to lactate, and it's essential. Oxytocin's one very unique job is lactation. It even reduces hypoxia. It allows the newborn to survive the transition from living inside the mom, where its oxygen's coming through the umbilical cord, to outside, where it has to use its lungs. Most important to what I'll tell you today, though, is oxytocin's an anti-inflammatory. It has some other nifty jobs like supporting telomeres, mitochondria, the microbiome, and much more. Now, our big problem, the reason we as humans may be especially dependent on oxytocin, is that we got up on 2 feet and had bipedal locomotion. We also have a very big cortex and a skull that protects that cortex. And we have a comparatively small, rigid pelvic girdle. I guess there are arguments about how important that is, but it definitely gets in the way of having the kind of large opening that a gorilla shown in this slide does. A little bit of extra space and a smaller head would make birth easier. So what oxytocin seems to do, among many things, is it allows the strong uterine contractions we need to get the baby from inside to outside. Oxytocin, as I mentioned, mediates cues of safety. This is very important to explain the evolutionary biology, the benefits of what we humans call social support, and our capacity to co-regulate with others across the lifespan. So oxytocin is a central element in mammalian motherhood. Hormones, including oxytocin, act on the brain, autonomic nervous system, and they're facilitating birth. They're allowing lactation, as I just said, but they're also buffering fathers. Males are releasing oxytocin in the presence of the babies, and that oxytocin gives them benefits that are similar in many ways to those that mothers get. Mothers and children, though, need oxytocin right from the start, the oxytocin that the baby experiences in birth, and especially in early life, are setting a pattern of stress reactivity or reduced stress reactivity throughout the lifespan. The other side of the coin, fear, anxiety, and pain. These are primitive behaviors. They aren't limited, of course, to humans. They're adaptive and especially important under acute conditions. So time, something that's happening right at the moment, is when it's especially important to have the so-called stress hormones. If we overreact, though, or continue to react for too long to these stress hormones and to threat, this becomes maladaptive. Fear can cause disease, and in that context, sociality and safety become a healing device. So oxytocin permitted the evolution of the mammalian nervous system, eventually the evolution of what we call the human nervous system. So you see the cortex getting bigger and bigger in this cartoon, and the cognitive experiences we call safety. A side point here, our ancestors were not crocodiles, and they didn't really use oxytocin, I think, at all. But notice how tiny the brain is relative to the body of the crocodile. We have a big brain. It's trying to take care of that brain. That's one of the main tasks of oxytocin, both for mother, for baby, and throughout life in both sexes. So this evolution of a modern solution to the stress of life, as I called it in some papers we've written, it really started in the beginning. But the hormones, which you don't need to worry about on this slide, are very basic hormones like amino acids, neuropeptides, steroids. A variety of molecules existed, we don't know for sure, but let's say at least 541 million years ago. That number is used because that's the point at which, according to geology, the Cambrian explosion began. And this was the point at which oxygen increased, as far as we know. No one was there to see it, but it can be seen in the fossil records to some extent. And what happened was we had to deal with a very volatile molecule. The same molecule that kept us alive also caused us to have inflammatory effects, so-called oxidative stress. In other words, we're rusting. And oxytocin, sitting at the top of my story as I'm telling it to you, allowed mammals to live, and not all mammals, well, all mammals breathe air to some extent, but not all mammals live on land. But it gave us a particular hormone that was primarily anti-inflammatory. And the ancestral hormones that had come before, which I'll tell you about in a minute, like a molecule called vasopressin, these over time are mostly pro-inflammatory. In other words, they're working to rust us. So all of this started a long, long time ago. And where we stand right now is we have a mammalian nervous system that is unique in birds have some of these features, but mammals are somewhat unique in needing a secure social environment. We depend on others, attachments, social communication. All of this is necessary for physiological and behavioral homeostasis. How do we know this? We know it from a huge scientific literature, and we know it from experience. So what happened is that we became dependent on others. Humans really don't do very well in solitary confinement, as we learned during COVID, in isolation, because we have nervous systems that are designed to regulate themselves based on the presence of others. And internal to that are emotions and behavior. And this is especially true in humans in early life. We know this is true because every so often we either accidentally or on purpose deprive ourselves of this environment. And what happens is vulnerability to mental and physical dysfunction will begin to emerge. Remember, time matters. And so over time, this actually can get worse. The two hormones I'm going to tell you about, oxytocin and its sibling, emerged as a kind of solution to this problem, but also giving us the advantage of others. So oxytocin does not act alone. It has a sibling, meaning they were born from the same ancestor, not brothers and sisters exactly. But oxytocin and vasopressin, or sometimes they'll talk about arginine vasopressin, these two molecules are so similar that they can talk to each other's receptors. This is really critical to trying to study them, makes them quite hard to study, but it also makes them very adaptive. Vasopressin, as well as like oxytocin, has an adaptive function. What it does is it permits the defense of self and even others. It seems to facilitate vigilance, hypermobilization, territoriality, so-called sympathetic autonomic arousal, and even fear. The problem is that chronic exposure to threat hormones, including vasopressin, is damaging to both the brain and the body. We can see that in a scientific example that was completed recently with a colleague, a student of mine, but also a major in the United States Air Force, Alex Horn. So what Alex did was he found 3 types of intense stress. The one on the right were people running ultramarathons. In the center, the one on the right were healthy first responders taking a course to become SWAT team members. According to Alex, who himself is in the military, it was a good bit of his life, this was the most intense thing he had ever seen. SWAT training is very, very hard work. And then he found a group of people on the left who were veterans in a program to treat post-traumatic stress disorder. The hormones that he studied, he took these samples, my lab ran them for him. He found very high levels of vasopressin compared even to those other 2 groups. And vasopressin, remember, is kind of a stress hormone, and half the level of oxytocin. What do we conclude from that? Well, this is not an optimal pattern. We know a lot about PTSD, and this is one of the first studies to really show what might be causing some of the symptoms. So the person who defines themselves as traumatized had, in this study, which was, let's say, done blind, we didn't know, these people, these assays were all run without knowledge of who they were. They had very low oxytocin, very high vasopressin, and they were in a state in which it was very hard to heal. They have a trauma history of some kind by definition, but they probably have less access to the healing powers of oxytocin and almost certainly higher levels of chronic inflammation. So this picture is just to show you what I think is going on. Basically, vasopressin and most, not all, but most of the hormones that are called stress hormones are actually pro-inflammatory. They are fast strategies of defense. If there's a virus or something acutely emerges, an emergency, vasopressin tries to come to the rescue. Oxytocin essentially is a fire extinguisher. It's acting as an anti-inflammatory and an antioxidant. So it's giving us this capacity to live in the high oxygen environment of Earth. This is a slide I showed you earlier, and I only want to remind you that over time, oxytocin appeared, and it has all of these miraculous functions. So in summary, oxytocin is a comparatively modern hormone and one which I argue allows us to be human. It's been associated with compassion and empathy. It is unique to mammals, although birds have their own version, another molecule called mesotocin. But what happened in mammals as we became more and more dependent on others and on birth and on nursing our young, we developed a series of adaptive strategies. These are based on sociality and, of course, cognition, and oxytocin supports all of that. Oxytocin has a unique role in mammalian sociality, and it helps to explain what people call the healing power of love. And I would love to go through with you or share with the audience the basic research that supports this. But let me say here, if we ask as an end to this little story, what is love? What are its origins? How does it heal? These are big questions. We don't have all the answers, but we're beginning to see and can say for sure there's a biology of love. There are relationships, and together these can help us. What we all want to do, I think, right now is save the world, save ourselves, heal our bodies and minds. And we've only in the last 100 years begun to appreciate how important biology is to that task. So I want to end by saying this is the power of love. It originates in the biology of birth and lactation. It allows us to bond to and support others throughout life. Dostoevsky said it very clearly. The soul is healed by being with children. It's critical that we support and love the next generation, our children and each other. Using this new knowledge we have, we can understand we're not only supporting ourselves emotionally and others emotionally, we're promoting our own health and healing as well as those we love. Thank you.